Uh, so I'm going to talk about regression models, and the basic problem that most people don't know how to do regression analysis correctly. Furthermore, the textbooks do not teach it in the right way, so it is not really their fault. Okay, so let me start by saying that one of the basic ideas that is required for a correct analysis of a regression model is that the assumptions are valid. We might call this the axiom of correct specification. In fact, we could call this is going to be my topic in the sense of for this lecture, that a regression model is valid only if all of the assumptions of the regression model are satisfied. Now, everybody who takes a regression course studies the assumptions of the regression model. Magar, nobody knows why these are studied, because after you study them, then there is not much mention that is made of them. So, one of the key assumptions is that you have the right model. You have all of the right regressors. You have the right functional form. All of the regressors are exogenous. The model remains the same in every period. It doesn't change from time to time. The parameters don't change. So there are a huge number of assumptions. A small number of these assumptions are sometimes tested. But most often, people don't actually even test those assumptions, and they assume that the regression. So, for example, we have a paper that has been submitted to our PDR. In the paper, the author says that he wants to study the relationship between FDI and economic growth. So he runs a model in which economic growth is on the left-hand side and FDI is one of the variables on the right-hand side. And then he says literacy also matters, so he puts in another variable which is called literacy. And then he also takes interaction terms, so he takes literacy and multiplies it by FDI. And then he runs the regression. He gets a high R squared, and these coefficients are significant. So he concludes that this is a good regression. And then he looks at the coefficient on FDI, and he says, okay, so if I increase FDI by so much, the impact on economic growth will be so much. Now, this is what people are taught. We were having interviews for lecturers recently, and nearly everybody responded to this question in the same way. So suppose I ask you that I want to determine the effect of health on economic growth. So what will you do? If you look at the WDI, World Development Indicators data set, you will find variables related to health. So something will be, there will be a variable on hospitals, there will be a variable on access to clean water supply, there will be a variable on number of doctors per population, and a few other variables. So you take all of those variables and you put them on the right hand side, and you take economic growth on the left hand side, and then you run a regression and you're off. You have your thesis. So now the question is, can both of these people be right? And the first person is telling us that here is the equation which is says that economic growth depends on foreign direct investment and on literacy, and the other person is running the regression on economic growth and on health, and they are both coming up with their conclusions. So what does the axiom of correct specification have to say about this? Can anybody answer this question? Can both of those authors be right? Yes? No? How many votes for yes? How many votes for no? Okay, so why cannot both people be right?
Some other cases that might be the health effect is quite related with the productivity of labor. So in a sense, we can say that FDI is far more related with the economic growth, rather to say that health is quite related with economic growth.
No, okay, all of these are good intuitive understandings, but there is, you see, the axiom of correct specification says that your model is valid only if it is true. So can both of these be true models? It is impossible. The FDI model says that health does not matter because the health variables are not included. The health model says that FDI does not matter because FDI. So either the FDI model is true or the health model is true, or both are false, but it is impossible that both can be right. It is impossible. There is only one true model for economic growth. And if you have it, then your interpretation is valid. If you don't have it, then your interpretation is wrong. There is only one true model. This is the very serious problem which textbook does not mention. Even though it is written there, yani it is written what is written implies what I am saying, but this point is never made, because if you made this point, you would stop doing econometrics. Because if you have 10 variables only, then if you look at all possible combinations of regressors, that is 2 raised to the power of 10. That is more than 1 million. So you have more than 1 million possible regression models, only one of which is correct. So what is the chance of your getting the correct model? But if you don't get the correct model, and this is assuming all models are linear. Now if you have log forms and non-linearities and other functional forms, then your chances are like this is an ocean, and your chances are finding is like chances of finding a drop of water inside the ocean, or a speck of dirt inside the desert. So you see, you cannot run a regression model like this, which everybody does. Yani, suppose I want to find the effect of health. Well, this is how the people do it. I mean, I'm not taking this example out of my mind. This is one of the theses that was written, that was presented at our interviews. That Somebody had written a thesis on health, and this is what they had done. Now, the question is, suppose that, okay, you are running this model. Our own students and faculty have written papers like this. We have published papers like this in the PDR. Now, suppose you run this model that I have GDP on a lot of health variables. Then, if this model is right, then there are 1,000 papers which people have written on GDP growth. 1,000 people, literally this is true, more than 1,000, and none of them has included health variables, so all of those papers are wrong. If my paper is right, then all of those papers are wrong, because they have ignored the health variable. If those papers are right, then my paper is wrong. So there is a very serious problem which is simply not mentioned in textbooks. So the question is, what can be done about this? There is an approach which is called the encompassing methodology, which is due to David Henry. And I will talk a little bit about this, but I will also show you some examples to explain why this is such a serious problem that people don't understand. Oops, what happened here? All right, so this is a World Bank data set. I am going to take this household consumption series This is the Algerian household consumption series. Oops. This is the Australian GDP series. Okay, so now Algeria is in Africa, Australia is somewhere else. So if I run a regression on these series, there should be no relationship, right? I asked this question of one of the people who were in the econometrics interview, that I take two variables, they have no relation. I take Nigerian GDP and I take Bolivia's consumption, or Nepal's GDP and Chile's consumption. So will there be any relationship? So obviously not. These two variables are unrelated. Our regression theory says that if you have two variables which are not related, then there will be no relation. Now we have we can run regressions here. Now I'm going to run a regression. Y range, X range, Y range is now A5 to 54, that's Algerian consumption, and then B5 to B54, that's Australian GDP. I think we are all right now. Output range. यहाँ पे ले आते हैं. Okay. Here it is. Now the R squared is 71%. You see now the x variable coefficient is 0.047. So the consumption in Algeria is about 5% of the GDP in Australia. The coefficient is highly significant. T statistic is 10.9, standard error is 0.004. So if you look at plus or minus 2 standard errors around this coefficient, 0 is very far away. So now we conclude that actually people think that the consumption in Algeria is determined by the GDP of Algeria, but it is not true. What is actually true is that however much GDP occurs in Australia, 5% of that is consumed by the people in Algeria. So R squared is good, strong, 70% is pretty good. And and you can do this on any two countries. So what does the axiom of correct specification have to say about this? Yes? What is the problem? Why can't we?
Both variables are influenced by the time.
How is that?
Both variables are influenced by other variable, which is
No theoretical background.
Theoretical background. You see what happens is that this is a good question, but it is fairly deep. Theoretical background is an important missing element which is not taught in your textbooks. Suppose I go to this health person and say, okay, you are saying that the health variables are causing GDP. How does it happen? This is the real issue, which is mentioned nowhere in the textbook, but it is one of the most fundamental issues in understanding regression analysis. And that is why a crucial component of any good regression analysis must be an historical and qualitative analysis, which nobody is doing, except that I tell my students to do this. Because you have to establish the causal chain. The causal chain does not establish by numbers. You have to go and say, okay, when people are healthy, then they work harder, and so you have to look at missing hours of work and how they are related to health. So you have to think about how the health variable affects. Similarly, for FDI, you can't just run a regression. Okay, here's my regression, R squared is high, coefficient is significant, therefore GDP effects. But still, I think the main point people are still not getting, which is the axiom of correct specification, which is the underlying everything. This regression interpretation is true only if the regression is valid. The regression is valid means that I have all of the right regressors and none of the wrong regressors. Now, are there any missing regressors in this equation? In the Algerian GNP, Algerian consumption on Australian GDP, are there any missing regressors? Yes. So why? How do you know कि होना नहीं चाहिए? Well, you see, if I say that health matter, why? Yani Australian GDP has an effect. World trade is linked, so you cannot exclude it like that, can you? देखो, there are good arguments and strong arguments, and then there are weak, and so you have to learn how to make strong arguments. When you say that something is a mistake, then you should be able to say something which will be convincing. Now, okay, now I have put the Australian consumption in here. Oh, that is not what I wanted. Actually, what I wanted was something else. Okay, now I'm going to put in the Algerian GDP. देखो बात ये है कि there is a very important fundamental missing variable from this regression. What is the missing variable in the regression of Algerian consumption on Australian GDP? क्या हुआ? Obviously, हाँ. Theory tells us कि consumption function में the consumption is a function of the GDP of the nation. So once you have a most important missing variable, then all regressions are wrong, which exclude the most important variable because you have a missing variable. सही है ना? If you have, this is called misspecification analysis. Everybody has studied this theory, but somehow this theory is never used. So students are never taught. This is the very strange thing about the econometrics textbook. They tell you the right things in bits and pieces, but when it comes to the application, everything is forgotten. And that's why our students produce these hopeless theses and they answer these questions in a hopeless way, which is completely wrong, and they have no idea, even though these things are there. So, if you have the missing variable, then misspecification analysis tells you that because of the missing variable, the equation is misspecified. Now, there is a practical aspect to this also, in the sense that if you have if the missing variables are minor, they have small effect, then excluding them only has a small effect on the regression. But if you have a major missing variable, then everything is completely wrong. So here we have a major missing variable because the main determinant of GDP has not been mentioned. Now, according to Keynesian theories, the GDP growth is determined primarily by the investment. The investment in that country is the exogenous variable, and the sentiments of the investors, they drive the economy. If the investments are confident and bullish and they are putting a lot of money, then that will cause growth. If the investors are not investing, then there will be no growth. Now, what do you think of the health and the FDI regressions, which were actual papers, one was a thesis that was passed and approved and somebody got their MPhil. The other was a paper that was submitted to PDR and the author appealed to me, okay, my perfectly good paper has been rejected by PDR, please help me and get this published. So what do you think is the problem with these two papers, the health and the FDI? Yes, please? What is the specification error? Which is the missing variable? GDP is what's being, is the dependent variable. Huh? Which other variable? What is the primary determinant of GDP growth? Investment, according to Keynesian theory. If investment is not present in the equation, then the equation is majorly misspecified. Now let me show you what happens if I run the regression. Okay, so that's A5 to A54. अच्छा इसको पहले कैंसिल कर दें. असल में वो Excel में the regresses have to be right next to each other. It cannot handle. So what I want to do is I want to run, first we run Algerian consumption and Australian GDP, and now I want to run, oh achha, theek hai, I need to put that in here. I want to run it on with the missing variable. So I want to put Australian GDP and Nigerian GDP. Algerian. Okay, so now I have Algerian consumption and then Australian and Algerian GDP. And now I'm going to run the regression. Okay. So I've made the regresses from B5 to C54, which is the next two columns. What that means is that I've got Australian consumption, Algerian consumption on both Australian and on Algerian. So I'm going to put this L5. Which formula? क्या हो गया? है? X range में प्रॉब्लम है. ओ अच्छा डबल डॉलर आ गया यहाँ पे, सही है. Overwrite, okay. Okay, so now the R squared has gone up to 88%. Now it's very interesting. The first X variable, this is Australia, GNP, and this is Algeria, GNP. So now we run Algerian consumption, and we find that Algerian GNP is very powerful, important, and there is a 50% marginal propensity to consume. But Australian GNP is not irrelevant as it should have been. It frequently is in these equations. But actually Australian is very strong, significant, and it has a negative effect, negative 2%. And this is standard error is very low, 0.008. T statistic is minus 2.5, which means that it's you see, if you look at the p value, it's 0.15, which means that it's significant at not quite 1% level, but 1.5%, which is significant at 5%, for example. So Australian GNP is still significant. Again, this is most likely just a wrong result. And the wrong result is because we have excluded an important variable. Now you have to understand, you have to use your brains, you have to understand why this is happening intuitively without any formulas. Why did we get a positive strong coefficient when we ran Australian GNP directly, and a negative one when we put in the right variable? Here, this is the Australian GNP, Now the Australian GNP, if we just run Australian GNP, then the effect is 5%. 5%, so a positive coefficient, and the effect is that if Australian GNP increases, Algerian consumption will increase by 5%. Now the second regression is saying that if Australian GNP increases, the Algerian consumption will go down by 2%. So which of these is right? Now you have to understand. Yes, okay. So first, the one question is that why we have positive coefficient here. That is something you can answer. Why we have negative over there, that's not so easy. But the implication of this, notice that suppose that investment is the key determinant of the GDP growth, and it is not present in your FDI equation, which it is not, then can we even say that the sign is right for the FDI? After you have omitted the most important variable, then nothing can be said. Whether it's positive contribution or negative contribution or no contribution, this is what the axiom of correct specification says, that unless you have the right equation, all your interpretation is wrong. So if you are missing a primary variable, then your regression is wrong. So this paper is completely wrong. Another, nearly every paper that we see makes this type of mistakes. Nearly every paper that we submit makes this kind of mistake, that the primary variables that are important are missing. Now, one very important thing that you can understand here is why is Australian GNP coming out positive and significant in this equation? Because what? Because what? Huh? Trade between, no, that's wrong. There is in fact very little trade between Australia and Algeria. Very, very little. What is the main determinant of Algerian GNP, Algerian consumption, according to economic theory? Excuse me? Main determinant of Algerian consumption. Income, exactly. Algerian income. Excuse me? No, foreign aid is not the main determinant of consumption. Algerian GDP, if you look at your microeconomic theory, consumption is a function of income. That is the primary, main, most important determinant. So, when that variable is taken out, then everything else acts as a proxy for this variable. Because that is the missing variable, that's the main determinant. So what do you think is the relationship between Australian GNP and Algerian GNP? Both are increasing functions. Both will be positive. Basically, GDP is growing in all the countries. So all of them will have positive correlation. So this Australian GNP is acting as a proxy for the missing variable, which is Algerian GNP. Since this variable is strongly positively correlated, we can check it actually easily. Check it equals correl of B5 to B55 C5 95% correlation between Australian GDP and Algerian GDP. And this will always be the case for any two GNP series because they are all strongly increasing. So, if you have a missing variable and that missing variable is the primary variable, so you have to distinguish. If you are going to do real regression analysis, then you have to, there is a very important difference between big primary variables which are strongly determining and small variables which have minor effects. Again, this is something which people don't understand. If I want to determine the effect of health on GDP, and health is a minor variable, say it has a 5% impact on GDP, then if I'm running a regression on 25 points of data in Pakistan, for example, it is impossible to find this effect because there is too little data to pick up a small effect. It's just something which is intuitive. If you want to pick up a small effect, you have to have a lot of data. If you want to pick up a big effect, if you want to ask what is the effect of Pakistan GNP on Pakistan consumption, you can do it with 20-25 points. But if you want to find out the effect of doctors on GNP, you cannot do it. There's not enough data, or with 20-25 points annual data. You might be able to do it in some other way. You can do it by, for example, assessing what is the effect of the labor force hours on GDP. Now, labor force hours will be a major determinant because production function is F of KL. So now if you find out the effect of labor force hours on GDP, then you ask how much does the medical factor affect on the labor force hours. Again, this is a strong effect, so you can trace it with small amount of data, then you will be able to find out. But if you directly affect GDP on, if you look, so by breaking it up into the causal chain, this is very important, which nobody knows how to do, and it is not taught in the textbooks. If you want to affect, and this is actually related to Maria's question, that what is the real effect? And you have to go behind. You cannot just look at the numbers. You have to look at the real world causal sequence. What is the mechanism by which health factors will affect GNP? And you have to trace the causal chain. Okay, one important effect of health will be that people will not be able to go into work. So you can get data on sick leaves in government organization, how many times people are applying for sick. You can get data on in hospitals. You can take a survey and find out how many people who are in the hospital they are working and they are off from their jobs. So there are various ways you can get an estimate of how health affects hours worked, and that should be relatively easy, clean relationship with short causal chain. Then you can do estimation, and then you can go on to the other step, which would be how much hours affect GNP, and then you can get a small, and even if the health hours take like 5% or 10% effect on labor hours, once you have an impact of labor hours on GDP, then you can use that to get your estimate. But you cannot go directly because the intermediate variable is missing. So one of the theses that was proposals that were submitted was that we want to assess the effect of migration from Azad Kashmir on the crop yields. Now, this is the kind of nonsensical idea that students are coming up with for their thesis proposals, that I take two variables, nobody has ever done this before, so now this is a thesis topic. What nonsense. This is not how it is done. Yani, if you, as I said, if you have only 10 variables, you have 1 million regressions. So 1 million students can write theses because there will be 1 million regressions which nobody has done before. There has to be some sense in that regression. Now, if migration has, what is the crop yields? Crop yields depend on, how much seed you put in, whether you run the tractor, whether you put in fertilizer, weather. These are your primary variables. If you take out all of those variables and you run a regression, you will get something, because what will happen is that when you take out the significant variables, then the insignificant variables take the place of those significant variables, and the coefficients. This is exactly what you are taught in mathematics, but nobody explains the meaning. You are taught, if you take a good course in econometrics, they go through the formulas for the bias when you have a misspecification. If you take out one of the variables, you can calculate what the bias will be if you put in the wrong variable. It's a very complicated formula and meaningless, but basically, if you interpret the mathematics, it's saying that this variable is trying to fill the place of the variable which is missing. And so the coefficient will be according to how it relates to the missing variable. Here we have a very simple situation. There is only one missing variable, let's say. That is the Algerian GNP. So everything will depend, the coefficient will depend on how the variable correlates with this missing variable. But now, after you put in the missing variable, then there are still other determinants. We've got 90% of the way, but now there's 10% left, and there will be other variables which will be important. Now, now why this is coming out negative? Well, probably because after you account for the Algerian GNP, then there will be other variables. Maybe it's exports of Australia. Again, you see, in order to find out, we have to study very carefully what is actually going on. This is again real world situation. For example, suppose that Australia and Algeria both produce oil. Suppose, I'm not sure. And so, when the Australian GNP is strong, they are exporting more oil, and this cuts into the oil exports of Algeria. So then that would explain the negative correlation. But that doesn't mean that this is a good regression. Then we would need to put in that causal chain in order to understand what is going on. So you have to understand the real world in order to understand how to do regression analysis correctly. And this is unfortunately never explained in courses. So, the axiom of correct specification is a very dangerous axiom. It says that you can interpret the equation validly only if you have the right equation. The chances of your having a right equation are 1 in a million, so you're dead from the start. There is no chance that you have, and that is why your econometrics textbooks don't even mention this problem, because this problem is so great that we can simply dump all of the articles that we see into the garbage without even looking at them, because what are the chances that the author runs a regression and says, okay, this and that and blah, 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 but everything depends on the assumption that he has got the right model, and the chances of getting the right model are just not much more than zero. So what can you do to avoid this? Well, this is what the Henry methodology does. What people normally do is that they start by normally what we do when we run regression analysis is we start by taking some simple model, and then we test this model, and if the test work, then we stop. That is, if you have a strong R squared and the coefficients are good, then we say, okay, we have found the model. Now the thing is that, as I have said, everybody can find a different model, and everybody does. But not all of those variables, only one of those regressions can be correct. So I have a paper in which there is health, which is the explanation of GNP, another paper where it's FDI, and there are hundreds of papers. One of them is taking literacy, one of them is taking religious background as the source of the GNP growth. So everybody can write a different paper, but only one of this can possibly be correct, and most likely all of them are wrong. And in fact, if we take the simple Keynesian theory that investment is the primary determinant of GNP, then any paper in which investment is not used as a variable is automatically wrong. You can throw it in the garbage, and that means nearly everything that people are doing with GNP growth, and nearly everybody, a huge number of theses are written on what explains GNP growth, because today GNP growth is God. This is the thing that everybody pursuing, even though it is very harmful actually to go for GNP growth. But so here is a FDI growth paper. Then there is another paper on intellectual property rights and growth. And again, this paper takes these variables. Very well written paper. Here's GDP, here's IPR, International Property Rights Index, FDI, EFW, the Freedom Index, trade, GDP ratio, population growth, secondary years of education, and gross domestic investment. Now here he has put in the investment variable. So at least the major, the one criticism that the major variable has not been included is not applicable to this equation. And here is the analysis. GDP equals 121 times IPR plus 0.06 times FDI plus 33 times economic freedom, 0.01 times trade ratio 131.9 times population growth, and so on. So then he says the analysis clearly shows that the enforcement of IPR by 1 unit would significantly cause to increase GDP by 121 units. This is the coefficient is 121. So it means that in Pakistan we should start enforcing intellectual property rights. Because now, can we rely on this regression? Can we, you see, this is the thing that you are being treated like children. You are being told that these are games you are playing. But actually this is not true. Now you are in the top 1% of Pakistan. Tomorrow you are going to be heading the analysis and policy think tanks, and you are going to be in the ministries, and you are going to be, and if you are going to, actually just recently the commerce minister was called to question for why is Pakistan export performance not very good. So he did exactly this. He said, okay, let's look at, and he assigned the task to one of his staff, and they ran a regression of export growth on 4 or 5 variables. And they said, look, the problem is that we have too many tariffs, and we have this and that. And by running a regression like this, he came to a conclusion. Now, the question that I am asking you is this reliable? Should we, and once I have this regression, can I go out and say, okay, we have so many CDs that are being pirated, and nearly every one of you is running Word and Excel without unlicensed copies. So before you go out, please pay your fees for the $700 that requires to buy the Microsoft Word and Microsoft Excel. So that will increase the GDP of Pakistan. What do you think? So now, are we jokers that we should go and run these regressions and make these policy recommendations like everybody is doing, and people are running these regressions? And in the health equation, the girl who wrote the thesis said that, okay, this is what it is. GDP will increase by 10% if we increase health, so we should put so much money into doctors and hospitals and so on. Is this a reliable recommendation? Is this valid? Can we trust this result? Yes, what do you think? Can we trust this result? This guy has done a lot. This is much more sophisticated than others. He has done the integration analysis and the co-integration analysis and Johansen test. Yes?
Sir, according to your point of view, we cannot rely on this because there is 0% chances of correct models.
But this is my point of view. Yes, Khalid.
I think, sir, it depends upon how you are trying to interpret the result. For me, this may be the case because if you are getting a licensed copy of all the CDs, that means that economic activity would be recorded. For example, if we are buying a CD which is worth 5 rupees or 50 rupees, and vice versa, we are getting a licensed copy whereby we have to pay, let's say, 5,000, that might add up in a organized or sum up value of increasing the GDP also.
Okay, Khalid, what you are saying is that we can think about the problem, whether intellectual properties cause an increase in GDP or not, and we can apply our brains, and I agree with that fully. But the question I am asking is this regression result reliable? Okay, let me ask a second question. Suppose that I gave you an assignment to produce something which is almost exactly parallel to this regression. Yani something which is equally, yani this uses the same methodology, the same tactics, the same level of rigor. Could you get another equation in which this number would be minus 100, minus 100? Would it be possible? Instead of plus 100, can you get minus 100 here? Yes? Yes? क्या हुआ?
प्राइमरी वेरिएबल जो इसमें मिसिंग है इस इक्वेशन में इन्वेस्टमेंट अगर उसको इनकॉर्पोरेट कर
नहीं, वो तो है इसमें, इन्वेस्टमेंट है इसमें, GDI, ग्रोस डोमेस्टिक इन्वेस्टमेंट. How is that?
If we change the model specification transformation, if we take result may be changed.
Model specification?
Just अगर हम उसका log transformation लें,
Oh yes, yes. Currently we have this linear model. Suppose I made this into a log linear model. Suppose I put in quadratic terms. I take exactly these things, but suppose I put in interaction terms. Suppose I put in some other variables for the same variable, like economic freedom. All right. So suppose instead of taking the economic freedom index, suppose I look at the number of elections which are being held, the number of transitions. There are many other ways that people have thought. Suppose that in the trade liberalization, there are at least 10 different measures which people have devised for free trade indexes. One depends on the difference between the black market rate and the official exchange rate. Hundreds, yani. So each of these variables, I can find alternates. What would you think would happen to this coefficient? This will remain the same at 120 as I change these variables, or will it change? How much will it change? I mean, this is the question then. See, what I am trying to show you is that this is not an issue of point of view. This is an issue of reality. If I give this same exercise to another person to do, and he picks up a different series and he picks up a different data set, he will get a completely different result. This result is completely unreliable. If this result is completely unreliable, we cannot go around and start making policy recommendations on this. And not only is this folly, but this is completely, and this is what students are being taught to do. And once you understand what is going on, you can get the result that you want. Now, for example, one of my students, Zahid Asghari, I asked him to do the Granger causality test. So we experimented with a little bit of things that, okay, the data set is going on from 1960 to 2015 or 2010, so that's about 50 years of data. If you take out the last 5 years or take out the first 5 years, you get completely different results. If you change the specification, yes, from log to log linear or direct, everything gives a different result. And ultimately, if you learn about what's happening, then you can get all 4 results. X causes Y causes X, bidirectional causality, and no causality. And this is not just he showed this, but actually if you go in the literature and look at papers, you can find all 4 results for any one country. In fact, I have in one of my papers, I have collected, I think there are 15, 16 papers written on think it's export-led growth. And some people say yes, exports cause growth. Some people say no, growths cause exports. Some people say that there is bidirectional causality, and some people say there is no relation. And you can find published papers on all four. So if there is something valid in this methodology, then it should be reflected in the stability of the results. So it's not a question of point of view, it's a question of what is out there. So what can we do about this? Well, this is what so I say that in my point of view, there was a paper that was written in, this is the paper, Econometric Modeling of Aggregate Time Series Relations Between Consumers' Expenditure and Income in United Kingdom. This is simply a model of the consumption function. Consumption equals alpha plus beta y. This is the most basic relationship, very strongly theoretically supported, that yes, your consumption should be some proportion of your income. And in this paper he formulates the methodology, the Henry methodology as it is called. This is the beginning, the first paper. And my view is that if you don't understand this paper, you know nothing about econometrics. And if you understand this paper, then you have the beginnings of an understanding of econometrics. So this paper starts by saying that the Keynesian consumption function is one of the most thoroughly researched topics. But there is no consensus. Everybody who estimates the consumption function comes to a different result. And these different results are very important because they determine the investment multiplier, the marginal propensity to consume. They determine the short run and the long run impacts of government policy. Everything depends on the consumption function, because in Keynesian economics the consumption function plays a major role. If you have unemployment and the government wants to eliminate it, then they have to stimulate the aggregate demand. What is the aggregate demand? Aggregate demand is the consumption function. How much do the people want to consume? This is their demand. If the demand is too low, then there will be unemployment. If the demand is too high, then there will be inflation. So it's important for you to have a good idea of what the consumption function is. If you don't have it, then you will make policy mistakes, because the government is always trying to set the policy. This is the Keynesian theory. The government should try to find the level of expenditure at which the full employment level will be reached. If they put in too much money supply is one way to do this. There are two ways, monetary policy and fiscal policy. If you choose the monetary policy to be too high, then if you overshoot the target, you will get inflation. If you undershoot, you will get unemployment. Both of these are policy mistakes. So you have to have a good idea of what the consumption function is. But there is no, but if you look at the consumption functions which have been estimated in literature, he cites many of them, 1, 2, 3, 4, 5, 6, 7 different studies. All of them have different estimates. If you use one study, you will come to one number. Use the second study, you will come to other number. There is no convergence, and very big differences, not small differences. So, what is the problem? Why? So, first of all, why does everybody get a different result? So, what Henry says is that this is because we are using the wrong methodology. the most important thing for a methodology is that it should be cumulative. Cumulative means that knowledge should build. If one person puts down a brick, then the second person should build on top of that or besides that, so that if everybody starts putting a brick in different places, we will get a cluster of different bricks and there will be no coherence. So what this means is that when there is a collection of models on the ground, so person X has done one study, person Y has done another study, like we have here, Byron has done one study, Deaton has done another study, Henry has done another study, Bispham, Shepard, Wall, Townsend, Bean, all of these people have done studies. Now I can add an eighth study, and this is how people are working, that everybody has done growth, and now I'm going to add another paper on growth. People have thought about the effect of health but nobody has thought about the effect of haircuts. So now I'm going to go to the barber and get the haircut variable, and I'm going to run a regression of number of haircuts. It will be very strong and positive actually, because as the population increases, the number of haircuts will increase, and haircuts and GDP will be very strongly correlated. So we will have a new theory of the GDP. If everybody gets more haircuts, we will get more GDP. So then we will make policy recommendation that the government should go and increase the number of barber shops. This is actually what is going on. This is unfortunately not a joke. This is what's going on today in policy making. So, what is the solution? Well, one of the keys to Henry is that when I put down a model, I must also say that my model is better than anything that is currently in the field. So I must test my model against all existing models and prove that my model is better than every other model. Once we do this, this is the key idea of encompassing. So this is why when you do a regression model, you have to do a literature survey. Now I am writing a paper on consumption function, suppose, or on GDP growth, or on any other thing. I have to look at all existing work. I have to say that, in fact, my student Rahman, he did his study on determinants of inflation. So I said, okay, find all of the papers that have been written on inflation in Pakistan. Not that many, about 10, 12, many of them coming from Bide also. Okay, so one person has done inflation. So we take all of those 12 regression models. Now, our goal is to produce an inflation model which is superior to all of those 12. So now when I produce this model, I will have the best regression model for Pakistan among all existing models. So this is an easier problem than the problem of finding the one true regression model among the million. That cannot be solved, but at least I can solve this problem, that I can beat everybody else. Now that doesn't mean that my model is true. The next student to come along will find a model that will beat my model. But at least we will be making progress. My model is better than all others and his model is better than mine. So there is some continuity, there is some progress. So that is the key idea of the Henry methodology. So now, then there are methods of model comparison. So this becomes now key. Given two models, how do we compare them? How do I show that my model, just look at two models for the moment, because so I have a model which is the H model, and another person has a model which is called the W model. So now I must show that the H model is better than the W model if I am going to implement this methodology. So how can you do that? Well, there are two methods. The one that is used by Henry is the method for nested model testing. So in the nested model, what we do is we make a big model which includes both of the other models as a special case. So consider, for example, the health model and the FDI model. Both are explanations for economic growth. One guy is saying that the economic growth is a function of FDI and literacy and the cross product. And the IPR model is saying, putting in some other variables, let's say just IPR and investment, just for simplicity, or let's put in the third variable also. So there's a model for growth. Growth is a function of literacy and FDI. Another model for growth. Growth is a function of health. Another model for growth. Growth is a function of intellectual property rights. So now I build a big model. In this model, I must put in all key theoretical variables. If I don't, then the model is dead from the start. So in the model, I must look at, so one of the parts of your literature review is that you have to go to the theoretical papers, the ones which have not studied, which have not necessarily run regressions, and the theory explains how GDP growth occurs. So one of the theories is Keynesian theory, which says that the GDP growth depends on the investment. But there are other theories of GDP growth as well. And you look through the literature, you actually comb the literature, search the literature. You are now looking at where people who are doing literature review, they have no idea what literature review is, why they are doing it. So what they do is they say, okay, here's this article and here's what he says, and here's this article and here's what he says, and they just make a list of unrelated pieces of articles, and they said this is the rasam by which we start the ceremonies, and so we just cut and paste descriptions of 20 different articles. This is called our, like Tilawat al-Quran, we have to do this, and then we start the thesis. No relation between those 20 papers and anything that is written in the thesis. No, actually when you are doing your literature review, you are looking for very specific things. You are looking for regression equations, because every regression equation on a similar topic, you have to beat that in order to make your thesis. Also, you are looking at theories to find out what are the variables which the theory says is important. Because if theory says that a variable is important, you have to put it in regardless of whether or not anybody else has put it in. Like in this case, the theory, Keynesian theory says investment is important. You have to put it in. Because if an important variable is missing, your regression is wrong. So now we make the encompassing theory says you make a big regression model which includes everything as a special case. So we put in a model for GDP growth in which we have investment, and then we have the health variables, and then we have the FDI and literacy, and then we have the intellectual property rights. All of those variables are put in. Now, in this big model, every model is a special case in the sense that the FDI model says that the coefficients of IPR is 0, right? If the FDI model is right, then if that model is right, then he has excluded IPR. So what he is saying is that IPR doesn't matter. Otherwise, he should put it into his model. And similarly, the health variable is saying that IPR does not matter. And the IPR model is saying that health and FDI do not matter. So every model is a specification of zeros. A model says that these variables have 0 coefficients. Now, all of you, if you have had your regression analysis course, you know how to test this null hypothesis. that some coefficients, some variables have zero coefficients. There is an F test for this, and all regression packages have an implementation. So you can test all of those three hypotheses. Each model is one hypothesis, and sometimes it will happen that one of the models will be accepted and the other two will be rejected. This doesn't happen often, but sometimes it can happen. Most often what will happen is that all three models will get rejected. So if all three models are rejected, then all three models are wrong. Then what happens is that in your big model, you look for a simple model which is not rejected by the data. Maybe the model that works is the one which has investment and FDI but no IPR and no health. Then this is your model. So you find the best model, which is now when you present, okay, here's my model. I am saying that GDP growth is determined by investment and FDI, but not by IPR and health. Now, this is not just you took those two variables and you ran a regression and you came up with the results, but actually you have looked at all of the million models, because you put on all of the variables in there. So all of the million variables are a special case of this model. So you have found a model which is equal in power to the big model, equal in power to all of the million variables, million regressions, and it is not rejected by the data. This is the best you can do. This is the best you can do in the sense that you can never find the true model. This is one of the famous issues that, have you heard of Karl Popper? Karl Popper is a philosopher of science, and basically what happened in Western philosophy of science, they had the idea that science leads to true results and all true statements can be discovered by science. This was the idea. And so they tried to develop a philosophy to prove this, and they tried and they tried and they tried, and actually they came up with a philosophy which is called logical positivism. And if logical positivism is true, then science is the only way to get to true knowledge. Everything else is just guesswork. And for a long time, logical positivism was believed to be true, because the Westerns are very ideologically attached to the idea of science, that science must be the only true producer. So this philosophy proved that science was the only sole route to truth, so they believed in it, even though the philosophy itself was not very well established. So ultimately, this philosophy was studied by philosophers and examined in detail, and it was found to be false and ultimately rejected. And there are many people who showed the many flaws in this philosophy. One of them was Karl Popper, and Karl Popper showed that you can never prove anything by scientific method. You can never prove anything true, you can prove things to be false. So basically scientific methods relies on observations. So suppose that for 1 million years or 1 billion years, every day we observe that there is a sunrise. So the scientific methodology says that there is a scientific law. The scientific law says that every day sun will rise, and we have 1 billion observations that this is a true. So we can predict confidently that tomorrow also the sun will rise. But the problem is that this method of proof, which is called induction, is not valid, because tomorrow the sun could go nova and there could be no sunrise, or There can be some events like a meteorite comes in and destroys the planet Earth, and there is just no more sunrise. So even though you have some event which has been going on regularly for 1 billion years without any change, there is no guarantee that it will happen tomorrow. And that is why you can never prove a scientific law to be true, but you can prove it to be false. For example, people in Europe saw that all the swans are white. They didn't see anything else. So actually, in the philosophy of science, this is given as an example that there are two types of truth. There is mathematical truth, which you can prove, like the Pythagorean theorem, you can prove by logic. So it's automatically true. It doesn't depend on observations. You don't need to draw a triangle and check, because you have proven it logically. And then there is empirical truth, which is called analytic and synthetic. One type is analytic and the other type is synthetic. So the synthetic truth is that you observe. So for example, there is a law that all swans are white, because all swans in Europe are white. But when the Europeans went to Australia, they found that there is a black swan species. And this is a genuine swan in the sense that it can interbreed with the white swans of Europe. So they were separate. So this is why there is a phrase called black swan. Black swan means something completely unexpected. So again, this is an illustration of the proper idea that you can never, you can disprove things, but you cannot prove things. So when I put up a theory which is better than all previous theories, then so far it is the best theory, but just like all scientific theories, tomorrow somebody may come and disprove it, and there is no guarantee. You can never make a truth guarantee. But you can only say that up to now, nobody has found anything better than this. And this is the best you can do with a scientific theory. Now, so the key idea of Henry methodology is that when I produce a model, it must encompass. Encompass is standard word, means covers or surrounds. So I must encompass all existing theories. My theory must be better than everything that is currently on the ground. And I must be able to prove this. So one way to prove this is by the method that I have told you, which is called the nesting models. So I find a big model which nests all the other models within it, and then I test all the models and find a best model. So this best model that I find is automatically better than all existing models. The other method uses the theory of non-nested model testing. So here, if I have a health model and an intellectual property right model, I don't need to make a big model which covers both of them. There are a number of different tests which you can make, and there are a number of different methodologies. All of these are quite complicated, much more complicated than the nested model theory, but you can go to the books and find the tests and run them. So you don't have to follow Henry methodology in terms of nested method testing. The key is that you have to test, and this you can do. So now, what has been the experience? This Henry paper was written in 1970s. Interestingly enough, the model that the DHSY model, Davidson, Henry, Serba, Yo, they wrote this model in, when was it? It was, I have the dates. It was in the late 70s. 78, okay. Now, they actually completed this research in about 1975. and they found a model which was better than 3 existing models. The number of models that were there were so many, and in fact this is a useful technique, that instead of covering all the models, which would have taken a lot of time, what they did was they took classes of models, groups of models. And okay, there are some people who say that these are the relevant variables. These 10 authors have studied social variables, for example, and they have put in models related to freedom and health, and there are these people who say that exports, so then they have put in models related to exports, imports, trade, huge number of trade statistics. And then there are people, I'm just giving you an example of how to do this kind of analysis for yourself, because if you go out in practice, you will find too many regression models to compete with. So what you do is you group them into categories, and you say, okay, one group deals with this kind of variable, and then from each category you pick one. And this is what they did. Okay, they said that, okay, here is one type of model which deals with the transfer function. Here is one type of model which deals with stationary models. Here is one type of model which deals with the interest rate and others. So I pick one model from each category. So they picked one deals with seasonal change. So they took 3 models, H, B, and W. And they said, okay, now our goal is to build a model which will beat all of these 3 models. And they succeeded. They built the DHSY model, which was better than all of these 3 models. But it is not enough to be better than the best. You should also have, the model should be good on its own. So when they did forecast testing of this model, they found that the model fails. The forecasts are very bad. They are rejected. You see, forecast, you have a model, your standard error of the model is, let's say, 25. So that means that when you make a prediction, C equals alpha plus beta y, then the error should be within plus or minus 25. That's one standard error. Or within plus or minus 50. That's 2 standard errors. If the error is 100, that's 4 standard errors away, and that means your model has failed. So immediately, and the key thing, very important, is that you have to make out of sample forecasts. Because if you estimate the model on a data set, then all the data is automatically fitted. So now if you make within sample forecast, you say, okay, omit one point and forecast, but that data is already in your estimate. So it's not a serious forecast. A serious forecast is when, okay, I estimated this model up to 1975, I didn't have the data for 1976. Now the 1976 data comes in and it has G and P and C, and let's look at how well our model fits on this. There you have no control, you have not looked at this data. So if your model works well on that, then you have some satisfaction that, okay, my model is valid. Now the model failed, and not just failed in a small way, it failed major ways. So they couldn't publish the paper, and they kept trying to find a way to improve the forecast performance, and ultimately they found out that one of the things that was happening in that period was financial liberalization. What that means is that it becomes easy to borrow money from the banks. And one of the ways that the banks made it easy to borrow money was that they were paying out, they said that, okay, if you have house, and what was happening in London and also in other places, is that the value of the house has increased a lot, and the people had loans on the houses, but the loans were taken out on the original value, which was quite small. So the people had a lot of equity in the house. The house is worth 100,000, and they have a loan of 20,000 remaining on the house. So they have 80,000 pounds worth of equity in the house. So what the banks introduced at that time was housing equity withdrawals. You can take a loan if you pledge, you take the house as a collateral. So a lot of money that was illiquid and unusable became liquid and usable because people could borrow money against the value of their homes. And so when they put in a variable like this into their model, then the forecasts became correct. And so then they published the paper, and the paper is published like this, and it has this. But the thing is that this last method that they used was actually against the Henry methodology. Because the Henry methodology says you cannot add an ad hoc variable at the end to fix things. The Henry methodology says that you should start with a big model which includes all models as special cases. And you should come to the right model. So now, if we take all ad hoc variables which are missing from this, there are too many. Now if we say that, okay, financial liberalization is the missing factor, then there are at least 10 or 20 or 30 variables which relate to financial liberalization. So if you actually and truly and sincerely followed the Henry methodology, then you would have to start by putting all of those variables and finding out the one configuration which is better than the rest. And this they did not do. So this is a practical weakness of the Henry methodology, that although it makes a very grand claim and it is very useful, and among the existing methodologies it is the best available, but still it is not the right answer and not the correct methodology. And in fact, I am taking faculty courses later on in which I will explain how, first of all, what the Henry methodology is, because most people don't even know that, and then what are the defects and problems with the Henry methodology, and how we can fix them, and how we can get to regressions which can be taken seriously, not as a joke that, okay, I run newspapers, and actually this is true. You run newspapers on regression, on GDP growth, this will, a number of newspapers being published, you get a very strong correlation. It is worldwide, globally true. And so the best way to improve our GDP growth is to just publish more newspapers. So, thank you. Subhanallah.